So this is a new program exercise where we're going to use a little Monte Carlo simulation using random numbers. So you can't use this for much, because what we are just going to do is to estimate the number pi, but we can calculate the number pi more efficient using other methods. But this is just an illustration of Monte Carlo simulation and random number generation and so on. So this is the pi estimation, where we have a function block, a program, and an instance data block that we have to call somewhere in main, one way or another. Okay, so a function block pi estimation, where the function block should estimate number pi by using two calls of the function random, and compute pi estimates as outlined in the pseudocode on the next page. Test the function, blah, 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 no program, and so on. Pseudo number or random number generator, Monte Carlo simulation, a casting function. We have to use some casting here to get a result that's not zero. Now we're going to look at the pseudocode on the next page. I think I can see it here, yes. So here we have some values. That value is falling inside our quadrant. This is the quadrant here to 0. What we are going to simulate number and get the numbers in here and do some calculations. So here is what the basis for this. Why it's called Monte Carlo simulation. It was used for gambling purposes in Monte Carlo, hence the name. So this is what you are going to program. And of course, this algorithm you can find on the net too, or maybe you could ask ChatGPT to give it to you. So that is what, but here is the pseudocode. Be careful now here, because here the pseudocode says do for several iterations, 1 to infinite. So what you do, generate a random number between 0 and 1 and another one. Set r is the square root of the square of these two numbers, and set inside the quadrant. Doing these calculations is always be inside this square here, and if the r radius that you are calculating here, this one, is less than 1.0, it's going to be in the red here. And then you increase the number of red here, and end if, and then end do. Be careful. This is a PLC. We are going to use a function block, because this random function has to store its seed somewhere and the values that's generating new all the time. So this do for several iterations of while true, that is your organization block here, the one that's cyclic that we are working in program main. So basically we just do this calculation and this calculation all the time. So the do here is our task that's running over and over and over again. So your program is basically this, what you have to do. And then we use, let's say, long integers to do the counting, because this could run forever. And long integer is 64-bit integer, which is huge. So it's running as fast as it can, and it's going to approximate this number. Hopefully we get 3.14 something out of this one. It depends on the random number generator, how good that one is. So this one here is your organization block, and this is always like this for the PLC. This do while true is your organization block that's running cyclic, if that's the type of program or task you are using, because your program should just repeat itself, iterate itself forever. This one should. And that was the theory behind it here too. So what it is with inside the square and so on to do the approximation. When you do this, okay, you are calculating for one quadrant and you have 4 of these, so hence the multiplication here by 4. So what you calculate is this divided by 4, but we have to, and the radius here is 1, so it's just to multiply by 4 to get the number pi out of this one. Yeah, so it's a little Monte Carlo simulation. A little more to Monte Carlo simulation. What you use it for is You could use it in a PLC too, of course, because if we have some problems where we have a parameter or variable that we know this one is going to be between 0 and 0.5, but we don't know exactly how our function is going to work for this one, this parameter or something, then we can test with a random number between 0 and 0.5 and check the outcome of a calculation and say, okay, this parameters and outcome, we could do an evaluation, so it should probably be 0.25 or something. So you could do some estimate for uncertainties, things like that. Usually you would never do this in a PLC. But this is just an illustration of Monte Carlo simulation and calculation, and there is a built-in function random it's called fcrand. It says in this template project that you can use, and in the compendium it's explained a little how it works and what memory it needs. But of course you could look in the function too, or the interface of the function, you see what it needs. There's an in-out parameter that you need to store in your function block. That's estimating the stuff. Yeah. So this was just a program. It's not going to be a long program. It's just showing Monte Carlo simulation. We use it to estimate the number pi. And if you're lucky, we get, and if you're probably right, you should get something 3.13 something, 3.14 something. And the longer it runs, it depends on how good your random function is, because a random function is going to repeat itself at some point in time. And this program is running as fast as it can. So if you look at these integer numbers that you are computing, this program in the template project is probably going to run on 1,000 times per second, or maybe even a little faster, depending on CPU. So you can see this program is going to increase fast, and you're probably, hopefully, going to approach pi, something 3.14 or something, as the output from this function, random function.